This is for Year 12 methods. It comes out of 5.6. It's question number 8, and it's about derivatives of natural logarithms. Okay, consider the function f such that d maps to r, where f of x equals log base e of bracket 5 minus x. Now this function is given to us in function notation, and we're told that d is the largest possible domain. So D represents the domain, but I don't know what that value is. Remembering that f is the name of the function, and it's about f of x. So this f refers to the name of the function. If it was h, then this would be h of x. If it was s, then this would be s of x over here. D refers to the domain, and R refers to the range. However, it's really the values of y that are available to be mapped towards. So it's the codomain. But R isn't the range. I'd have to work out the range. Okay, let's have a little look at this. So I've really got y equals log base e. Now I've got two transformations. I've got a reflection, and I've also got a translation. So I'm going to bring the negative out. The x will become positive, and the 5 will become negative. And I'm going to consider my transformations in the order DRT, dilations, reflections, translations. So I've got a reflection. X has been made negative, so therefore it's over the y-axis. And x has become x minus 5, therefore it is a translation 5 units to the right. So I've got an asymptote over here at x equals 5, and it's been reflected over the y-axis, therefore that's what my function looks like. So I can see straight away that domain D is going to be from negative infinity through to 5, not equaling 5, not equaling negative infinity. So that's what my domain is D. Okay, part A, find the exact coordinates of the intercepts. So I have y equals log base e of 5 minus x. To find the x-intercept, let y equal to 0. 0 equals log base e 5 minus x. My x is locked inside the logarithm, therefore I'm going to turn this into an exponential. E to the 0 equals 5 minus x. Move the x over, move the e to the 0 over. X equals 5 minus 1, x equals 4. Therefore, the coordinates, the exact coordinates of the x-intercept is at 4, 0. And that makes sense because that's at 4. And to find the y-intercept, let x equal to 0, so y will equal log base e of 5. Therefore 0 log base e of 5. So that there is log base e of 5. So that's part A done. Part B, find D. Well, I've already done that because by graphing I realised that D is the element from negative infinity to 5, not inclusive. And part C is use calculus. So I need to take the derivative with respect to x of log base e of 5 minus x. The derivative of a logarithm, say log base e of x equals 1 on x, so the derivative of this will equal, because I have a chain happening, 1 on 5 minus x times the derivative of 5 minus x, which is minus 1. Therefore it's going to equal negative 1 on top of 5 minus x. And I've got to show that the rate of change with respect to x is always negative. So the rate of change is the derivative. And my derivative is y equals -1 on top of 5 minus x, which is a hyperbola. It has an asymptote at 5, and since there's nothing added, it has another asymptote at 0. We normally sit here and here, but it's been reflected over the x-axis and the y-axis. Therefore, it's going to be in this position. And it would be in this position up here, except I have a restricted domain, and that domain only goes from -infinity to 5. So this is my graph of the derivative. And it always has negative values because it's below the x-axis. Remember, I'm not interested in the gradients of this, I'm interested in its values. And it's always below the x-axis, therefore it is always negative.